All right, let's keep on keeping on with the derivative here. Okay, we're going to do a couple of examples with just computing the derivative. And this is going to state, the directions will say compute f prime of x using, oops, that's kind of a little close there, isn't it? Using the limit definition of a derivative. Okay, all right. So here's our first one. F of x is equal to a negative x squared plus 6x. So notice it's not saying find the slope of a tangent line or a tangent at a specific point. We're now just straight up finding a derivative, so just the derivative. However, we do this exactly the same way with the limit as h approaches 0 of x plus h minus f of x all over h, right? So we're just plugging it in. All right, let's do our thing then. So f prime of x is equal to lots of algebra, right? These are super algebra intensive. So I plug in x plus h for both x's there, minus this negative x squared plus 6x all over h, right? So knowing how to plug that in, that's the key. Then here, this one is squared. So remember, back to that Pascal's triangle, or just the fact that it's a binomial squared, we know how to shortcut that. And then don't forget, you need to distribute this 6 and distribute that negative. So that becomes a plus and that becomes a minus. All right, let's do it up. Oops, go back to black I meant. F prime of, oh my, f prime of x is equal to the limit as h approaches 0 here of negative x squared plus 2xh plus h squared plus a 6x plus 6h. Oh, that's supposed to be an h. Didn't look much like one though, did it? Oh, that becomes plus when you distribute that. So I've got a plus x squared minus 6x all over h. Now don't forget, you need to distribute this negative also. So this becomes a negative, and a negative. Now, is there anything you can go in and cancel? Yes, of course there is, because there always will be, right? So this positive x squared, this negative x squared, this positive 6x, and this negative 6x. Now let's write what we have left over. So f prime of x, I'm going to scoot this up a little, oh my. Scoot this up a little bit. And the limit as h approaches 0 here of negative 2xh minus h squared plus 6h all over h. And now my limit as h approaches 0. Remember, you can't have that 0 in the denominator, so you need to factor that out. So factor an h out of the numerator gives me a negative 2x minus h plus 6 all over h. Then those h's cancel. So now whenever I'm looking at this derivative, it's the limit as h approaches 0 here of negative 2x minus h plus 6. Plus 6, I wrote an h, but that should be a 6. Now I'm taking this 0 and plugging it in for that h. When I plug a 0 in for that h, my derivative is just left with a negative 2x plus 6. All right, that is a derivative. It stands for the slope of a tangent line when I'm looking at a derivative, but it didn't ask me to find that. I'm not given any kind of a point. So all you're doing is just finding that generic slope right there, just that basic derivative. All right. Okay, let's do another one. Here is example 2a. We want to find dy dx using the limit definition of a derivative. of y is equal to the square root of x. And then, so that after we do all of that, then I'm going to have part B, find the tangent line at 4, 2. Okay. Okay. So first and foremost, we're finding our derivative. So f prime of x is going to be the limit here as h approaches 0. Now, I'm not going to write that formula out again. We've written it several times. Now it's just go time. So I'm going to plug in x plus h minus the square root of x. Now you see we have a radical. So when you have your radical, you're going to multiply by that conjugate. When you multiply by the conjugate, now here's something that people make an error on all the time. You're not changing the sign on the inside. That stays the same. That's stagnant. The only thing that changes is the sign in the middle. Everything else stays the same. All right? Okay. So my derivative is equal to the limit as h approaches 0 of, and remember with this conjugate, you're squaring the first term, so the square root of x plus h squared minus squaring the second term all over h times our conjugate. Now the beauty of this is plus x and minus x cancel out, which leaves me with just an h in the numerator. Now I'm going to get fancy on you here. This h cancels out this h, and there's just a 1 left on top. So what we actually have here is the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. Do you see that? Then when I go to plug this in, that makes a 0. And I'm left with 1 over the square root of x plus the square root of x. So I have 2 square roots of x is my derivative. Don't forget, that's a 1. Now, it actually told me to use dy dx, didn't it? Yeah, I just remembered that. So if I'm looking at my notation, f prime, remember we talked about this last time, f prime of x, dy dx, those are all the same notation whenever it comes for derivatives. And what we found, again, this is my generic slope of that tangent, right? That's the generic slope of the tangent line. So if I specifically want to know what's happening here at 4, 2, then part B, I've got my point of 4, 2, and my slope here is going to be f prime of 4, 1 over 2 square roots of 4. And we know the square root of 4 is 2, so my slope is 1/4. That's the whole point. Generic slope of the tangent line, getting that notation down so you know what's going on. Now I've got y minus 2 is equal to 1/4 x minus 4. So y minus 2 is a 1/4 x minus 1. When you add 2 to both sides, that makes it a plus 1. All right. The kicker to this is when you have that irreducible quadratic, then you're going to do your conjugate. Okay.